Welcome back, guys. In today's lecture, we will talk about mathematical expressions and also about comparison expressions. Right, for example, if we take this if expression, which we'll implement in the next lecture, we see the condition part uses the equals operator, and also we still don't have basic math operators such as addition, multiplication, etc. So we're about to implement them. And let's start from the very basic operation, plus. And our IR builder has multiple methods to create mathematical operations, for example, create add for addition, create mul multiplication, and others. And all of them are pretty much the same, so let's introduce the generic macro called genBinaryOp, that is generic binary operation, pass in the method name from the builder, and also the name of the temporary variable. Right, in case of addition, we call it temp_add. Sounds good. Let's introduce this macro, which accepts the operation and the variable name. And we use the trick from C++ with the empty do-while false loop, with the only purpose to create scope. Right? This loop is never executed, but the scope will be created. So the handling is very simple. We code gen the first operand, the second operand, and then just call appropriate operator on the builder. Right? For example, create add for addition. And that should be pretty much it. Now we can reuse this generic macro. Right, let's reuse for subtraction. Operation create sub on the builder. For multiplication, create mul. And for the division, we use create as div, that is signed division, and that should work. Okay, sounds good, so let's try and test it. Okay, execute. And we don't see actual add operation. This is the second time when we meet optimizing compiler directly integrated into the builder itself. Right, so take a look. Instead of doing add operation for 32 and 10, the builder just pre-evaluated this to the value 42 right away. Right, so already some optimizations happening at this stage. Now to see the operation, the actual add operation, let's use a variable. Right, let's allocate variable z, value 32, and then z plus 10. Since we need to load z, we should see the actual add operation. And that's exactly correct. As you can see, right, we allocate the variable z on the stack, we store the value 32. Then in order to use z again, we load it. Right? Remember, we have load store architecture here. And here is our add instruction, the variable z plus 10. And we also see the temp name, temp_add, which we used in our code gen. Okay, so that works. Let's now implement the comparison operator. And again, the builder has multiple methods. Let's start from the greater than operation. And also builder distinguishes signed and unsigned values. For example, for the greater than, we're going to use operation called UGT, that is unsigned greater than, and builder has appropriate operation, create integer compare operation, unsigned greater than. For the variable name, let's use the same temp comparison. Now for the less than, we use exactly the same, just instead of GT, we use LT, that is less than. Exactly the same we have for the equal, not equal, greater than or equal, and finally less than or equal. Okay, so this should be enough to work with the if expressions in the next lecture. Let's try and test it. Right, let's ask if x equals 42 and then use the equal operation. So that should return our Boolean expression, and this is exactly correct. As you can see, when we call the printf function, the temp comparison is exactly of type I1, that is the Boolean value. Okay, let's test the false value. So x greater than 42, which is false. And that's exactly correct. We see the value 0. Okay, so that's it for today. In the next lecture, we'll implement the if expression and we'll reuse our comparison operators. Thanks and see you in the class.